14 on page 424 reads, as shown left in my diagram, a certain I shouldn't say diagram when I'm reading design. Okay, but a certain design is to be painted using 2 different colors. If 5 different colors are available for the design, how many differently painted designs are possible? Okay, so we'll ask our who, what, when, where, and how questions, starting with the what question. What kind of problem is this? Well, it might be kind of hard to tell at first. It definitely doesn't seem like it's an algebra problem. We have a diagram, but it doesn't seem like a geometry problem, which leaves sort of those other 2 categories of numbers and operations or probability and statistics. And we actually probably would classify this problem as falling into the probability category because it's a permutation problem. So the what question, this falls into the probability category. And then when, this is number 14 of 16 here. So you're probably running a little short on time. And if you're uncomfortable with probability problems, as most of us are, this might be a good one to skip. The where question tells us that since this is at the end of the section, this is going to be a hard problem. Hard or difficult. And then how? How are we going to do this problem? So let's talk about different ways. If you can see at first glance that this is going to be a permutation problem, there's a pretty quick formula we can use to solve for permutation problems. But it might be hard for you to kind of recognize whether this is a permutation problem or a combination problem, or maybe you don't even know what I'm talking about when I say words like permutation or combination. And that's okay, because we can solve this thing sort of one step at a time, or exhausting all possibilities. We can also solve it that way, and I know that sounds like it'll take forever, but we'll actually solve it that way together, and you'll see that it actually doesn't take that long. So getting to the who question, are you going to solve this problem or not? And like I said before, a lot of us are pretty uncomfortable with these counting problems or these probability type problems, so if you want to skip this one and come back to it, that's up to you, and it's perfectly acceptable if you decide to do that. But we're going to go ahead and work through this here. So what I want to do first off is take a look at our diagram. And they tell us this represents a design where part of the design is in color 1 and the other part is in color 2. It kind of looks like a baseball, but I guess if I actually put the colors in there, it wouldn't. So what I want to do is I'm going to redraw the diagram. And since I have all these fancy colorful pens, we're actually going to use some colors. So we're going to let color 1, we'll start by assigning some colors here. Alright, so it tells us that we have an option of using 5 different colors. So we're only going to use 2 colors in the design, but we have an option of those 2. There's 5 different choices. So let's say our options are blue. So these are the colors we can choose from. Blue, green, orange, red, and I don't know why I tried to write it right there, but let's say our last option was purple. Okay, so let's talk about how we can find all the different designs possible. Remember that of these 5 colors, we can only use 2 at a time in our design, where these represent one color, the outside, and then this inside part represents another color. So what I'm going to do is I'm going to show an example of what that would look like. So let's say I'm using orange and purple as my 2 colors to start out with, and I'm going to let the orange represent color 1, and then I'm going to let the purple represent color 2. So notice when I do that, there's one possibility for the design, right? It can only look like this if orange represents color 1 and purple represents color 2. Now what if I switch which color represents the color 1 and the color 2? So let's say I change the purple to represent color 1 and the orange to represent color 2. Now if I do that, notice the design is going to have the same colors, but it's going to look slightly different because now the orange is going to be in the middle here, and the purple is going to be on the outside. So we see that for every combination of two colors that we use, there's two different designs possible, right? So if I'm going to use orange and purple, there's two different designs that I could make. I could either make this one or this one. All right, so for each combination of two colors, there's two different designs. Two designs per two colors. I'm just going to write that down so that we remember that property here. Okay, so now I'm going to erase this information here, and I want to ask you, how many different combinations of colors can we get? So now we're talking about what two colors can I use together? Well, I can use together any two colors, right? So let's just say, to make it easier, and this is the way I like to exhaust all the possibilities, is starting with this first one and finding everything that can be combined with the first one. So if I start with blue as one of my colors, I can have as my two colors blue and green. I could have blue and orange, or I can have blue and red, or I can have blue and purple. So notice there's four options there if one of my colors is blue, right? Now, what if one of my colors is green? How many options do I have? Well, I can have green and blue, I can have green and orange, I can have green and red, or I can have green and purple, right? Now, when I say that I can have green and blue, notice that I already counted that here, because blue and green is the same thing as green and blue, right? So I don't need to count that one twice. So I'm going to erase this here because we already got it and we don't want to double count something. So these are all the combinations with blue, these four here. These four in orange are all the combinations with green. Now all the combinations with orange that we haven't exhausted already, well, we've done orange and blue, we've done orange and green here, but we haven't talked about orange and red or orange with purple, so there's two more possibilities there. And then if we look at red, if we're exhausting all the possibilities going down the list, then red still needs to be paired with purple. So let's count our pairings. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and for every pairing, there's two possible designs, therefore there's 10 times 2, or 20 possible designs, which gives us answer choice B. Alright, so if you have any questions on this, send me an email or leave me a comment. I know this is a little tricky. We don't like doing these types of probability or counting problems, just because we typically don't do a whole lot of these kind of problems in our math classes, so they're generally fairly unfamiliar to us, which we don't really like. Notice I do want to tell you that had you been able to recognize this was a permutation problem, you could have just used the permutation function in your graphing calculator or the permutation formula if you know it, and it would have been 5p2, which just means that out of 5 things, we're going to permute 2 of them. And if you use that formula, you should get the same answer we did. Hopefully you do. If not, that's not very good news for me. All right, so the answer is 20 for problem number 14.